In this video, we present Avatar, a novel data-driven visual subgraph query interface construction framework for large data graph. The interface contains 6 panels. Panel 1 lets user generate useful patterns from the input data graph to support query formulation. Panel 2 lists all vertex labels on the data graph. Panel 3 reports the time taken and number of steps required for formulating particular subgraph query. Panel 4 is the query construction panel. Panel 5 and 6 contain the default and generated patterns of the data graph, respectively. Panels 2, 5 and 6 are automatically populated by Avatar. We shall now demonstrate pattern generation and visual subgraph query formulation using Avatar with real-world networks. First, we load the Amazon dataset and then configure Avatar to generate 30 patterns between sizes 4 and 10. The length of time required for pattern generation depends on the size of the data graph, the number of patterns to generate and the pattern sizes needed. Default patterns in Panel 5 are basic building blocks of network. The number of default patterns can be configured. Here, we provide an edge, 2-path, triangle and square as defaults for all datasets. The generated patterns can also be configured to display in different formats such as in a single page, 4 per page and to be grouped by size. We now demonstrate formulation of the visual subgraph query of a movie actor network. Suppose you are a filmmaker interested in making a movie involving Ben Affleck, Matt Damon and Gwyneth Paltrow. You can then construct this query to find a list of co-actors who have previously worked with these actors. We shall start by using pattern at a time approach based on the generated patterns. Observe that the canned patterns can be modified as desired. Here, we delete an edge. The patterns in Avatar are generated to cover as many data graphs in the dataset as possible. Note that Avatar is designed to select structurally diverse patterns and patterns low on cognitive load. Observe that the steps count in Panel 2 do not include vertex labeling. We do not record number of labeling here as they are same for both pattern and edge at a time. The pattern at a time approach took 1 minute and 1 second and required 5 steps using a default pattern and 2 generated patterns. Now, we shall demonstrate query construction with only default patterns. These patterns are generally small and more patterns are needed for constructing the same query. The default pattern approach took 1 minute and 29 seconds and required 6 steps using 6 default patterns. Now, we shall demonstrate query construction with edge at a time approach. In this approach, we construct each vertex and edge at a time. The edge at a time approach took 1 minute and 31 seconds and required 12 steps. Hence, as demonstrated by this example, a pattern at a time query formulation can be more efficient than query formulation using only default patterns or edge at a time approach. Now, we shall demonstrate the portability and data-driven nature of Avatar using a different data graph. We now generate 20 instead of 30 patterns for the road network dataset. Observe that we use the same interface for this dataset. Panels 2, 5 and 6 are updated accordingly based on the input dataset. Note that the patterns of the road network is different from that of Amazon. In summary, Avatar provides a common framework to construct the query interface of any source and domain centered on large data graphs.